Okay, so I am going to be talking to you about the Sandcastle workflow. This is a project that has been created with, as I mentioned, with some funding from Vast Connections, Code Plus last summer, and Data Plus the summer before that. It's also being supported by the National Endowment for Humanities, the Office of Digital Humanities. And my project co-PI on this is Phil Stern from History. And so what I'm going to talk about a little bit is the subject of the study, which is these early modern, I would say pre-modern views of places, and also the methodology, the technology that we're using to investigate them. So to move forward here, here's a couple of examples of the kinds of things that we're dealing with. These are our sources. These alternate with lots of different terms: bird's eye views, choreographies of places. These were actually very, very common methods for expressing places, particularly cities and the hinterland. And so on the left, we have an example of a project I've been working on for quite a while called the Book of Fortresses. And this is a source from 1509, 1510 that has about 150 drawings of castles and fortified towns by a Portuguese squire whose name was Duarte de Armas. He also does a number of plan views as well. And then on the right, we have an image of Lisbon from a far more famous atlas called the Civitates Orbis Terrarum by George Braun and Hans Franz Hogenberg. And this version was from 1572. We actually have an example of this in the Rubinstein Library too. So what is choreography? There are lots of definitions. Here's a few that I think help. So Richard Helgerson describes choreography. He says, choreography defines itself by opposition to chronicle. It is the genre devoted to place, and the chronicle is the genre devoted to time. So this idea of place-based imagery is really important because, and as I'll explain, we have plenty of methods for understanding spatial and conducting spatial analysis, particularly if we talk about things that are mathematical or in a gridded Cartesian system. But once we're outside of those systems, our ability to study these kinds of objects spatially kind of falls apart a bit. And so I think it's useful to actually describe choreography as well. And so this description I think is quite good. Several characteristics, this is according to Thomas Fregenberg, is that several characteristics explain the long-lived popularity of oblique views. They convey the visual appearance of a city as presented from an elevated, in fact, often an implausibly elevated position. They show the principal buildings, both sacred and secular, and to a very varying extent, give some impression of the fortifications. They allow the viewer to arrive at conclusions about the city's history, beauty, might, cultural importance, and wealth. In addition, such views almost always show at least some of the surrounding countryside, thus providing information about the geographical setting. And what I want to focus on here is that this is really not that dissimilar from the concept of a portrait. So these are in the way that a portrait is not necessarily always devoted simply to the way that a person looks, but that person's character. And in the same sense, people have written some interesting ideas of equating early modern portraiture to city views as well. That this is that these place-based images are trying to capture the character of each place. So the problem that we're trying to solve here is the most common method for studying historical maps tends to involve this idea of georectification. So this is a technique that focuses on the differences between the historical map and modern map layers. So this really is impossible. And the way I say it's not necessarily impossible, it's sort of fruitless to try to do this with choreography. Choreography does not apply mathematical perspective in its renderings, and it doesn't use modern survey techniques, which tend to divide space into a Cartesian grid. So this methodology, while kind of intriguing to show, oh, look how different these images are from natural topography or quote unquote modern base maps, doesn't really go beyond there. So these don't conform. So we're going to look at these things as pre-modern sources rather than what they tend to be used, which is sort of like decoration. I mean, this is the kinds of images that people put on the cover of their book and then never really engage with as spatial objects. So our initial geospatial solutions that we've tried, here's an example, just a walkthrough of the Book of Fortresses website, our project website, where what I'm trying to do is the first method we did is we tried to map every place that's in the book. And then we attempted to contextualize the images from the book in a 3D GIS using a technique that I just sort of refer to as billboarding, where you create you use a combination of the topography that they give you in ArcGIS Online combined with dense data that I've captured on site to try to get a rough idea of where these places are. And this is one technique that sort of allows the objects not to be sort of violently kind of torn and pulled apart. Another method that I've used in the past is to this concept of sort of like reversing georectification. So with georectification, we alter the historic map to make sure that it suits the modern topography. And in reverse georectification, the idea, which didn't really go very far for me, to be honest with you, was to try to take this space, bring it into another program, import a modern topographical map, and then begin to alter the topography so that it suits the historical image instead. So this is where we sort of attempt to grab hills and pull them up, right? The problem was that most of the imagery doesn't really bear even any semblance to the topography that might be at a particular site. So here we are dragging these hills around. So this was just an initial attempt. And as I said, it wasn't the most productive. So we moved forward with the NEH project, the Sandcastle workflow. And this is a real technical and methodological shift where we're trying to focus on 3D translation of 2D city views, regardless of their adherence to the modern built or natural environment. And so I think of this sort of like the sola scriptura approach, right? We're allowing the sources to speak for themselves rather than trying to make edits to them. So the first part of this process is we have to structure these images into data. And on the left, we have a demonstration of the supervisory web application that we use to create annotations. This is where we develop, and this is true computational thinking, and that we had to really develop a metadata schema that was going to be appropriate for our translations as well as for the objects themselves. So there are many different object types, from houses to churches to walls, etc. And as we go through the process, you can kind of see we trace the object, and then over here on the left, we start answering questions about them to say that this is a front facade that is, seem to have recorded a cough. Love that. So we have some questions in there that we answer as we go through, and that the idea here is to allow this data to be taken in this two-dimensional realm, and then through some really excellent work where I give a shout out here to Eric Monson. He wrote a Python script that allows us to take the JSON data that comes out of this, the supervisory program, and run some scripts on it. The scikit image library allows us to create a whole lot of individual file names that have the IDs that are associated with all of the sort of geographical location, the pixel location for each image. And then essentially what we do is we reassemble that object in a three-dimensional environment. We first put it on the two-dimensional plane. Then we use a number of, and this is in the Houdini program that we're using the most. This is where we actually use all of that data that we have. We get it back, and we begin doing some procedural modeling on that based on the data. So the data has been structured, and now we need to, with the help of some students over through Code Plus, they designed for our different classes of buildings and other natural features, ways of, in some cases, randomizing, but in more cases, reading the data and making it possible to alter the number of crenellations or merlons on the tops of towers, so that we get as faithful as possible of a reconstruction of those images. And Houdini is a visual coding system, really was fantastic to use this summer with students to help get them thinking about how procedural modeling is essentially a way of setting up rules that can potentially break if you push and pull things a little bit too far, and how to build really elastic systems. And here's just a quick slide that shows the way that Houdini works is to develop your own tools. It is very much a tool building kind of software. on the right is as of this morning. This is the most up-to-date version of our network. And I assure you that zooming in here, there's also kind of some embedded code that has already been kind of clustered in. So this is already the work of about 6 to 9 months of development. That allows us to do some simple things for each object, changing the number of Merlons, rotating towers, etc. And this is probably the most important video. I'm going to mute this in case there's another cough in here, which I hope there isn't. So in this video, I'm showing you just by sliding the ZTranslate right here, we're watching one of the towers slide into place into the 3D system. Whereas when you're looking through the camera, this is tower number 0 has not actually been changed during the process. So if I run this back for just a moment, as this is getting larger in this view from the side, you'll notice it doesn't change from that view. So because we've done the math to make sure that as it moves away on a vector away from the camera, the objects will appropriately get larger. And here you can zoom into the object and begin to make some changes that are particular to this particular object. Now, hopefully in the future, we're going to be able to make this a little bit more automated, but that's part of the process. And then just some brief conclusions here. We acknowledge that the conceit of the camera as a lens for viewing historical choreographies has to be procedural. So rather than creating this tool that makes it possible to have one translation of a potentially narrow or a parametric view or panoramic view, we really want to make sure that users are allowed to produce multiple hypothetical reconstructions very quickly. This is the end goal. This is August, what you're seeing on the screen on the right, where we bring all of our hard work from Houdini, which pairs very well with the Unreal Game Engine, in order to do the second thing that I'm talking about in this conclusion, which is that the spatial and the hierarchical scale in these choreographic images really can be kind of confusing. So the idea that when you walk up to these houses that they are appropriately scaled for the image, but they look like they're about 4 feet tall. Meanwhile, if you look up at the keep and you look at the flag at the top, they're something like 40 feet tall. So it tells us a little bit in terms of experience, what is most important to the choreographer. So the person making these, they're using a variety of observational interests combined with what we might call cartographic or iconographic interests. So objects are allowed to be much bigger if they're more important, and yet you still need to capture place. And that's the kind of thing that we really want to be doing. This is the probably last set. And then the last slide is the sort of it takes a village slide. The current team has 5 students on it. 3 of them are working in Houdini, a few working also in GIS, and there's a long team of previous teams working on the Book of Fortresses. We also had a team of almost 16 researchers that was building up our database of choreographic views and other kind of research through BAS connections that's not even on this list, but they deserve acknowledgement, I think, too. So that's it.